Welcome back to 9.1. Now we're working on example 2 for evaluating piecewise function. So let's take a look at example 2. Here we have f of x equals, now we have three equations that's inside. So let's take a look at the first one. The first one is 7x minus 1 with the corresponding condition x less than negative 3. Then the second equation is negative 2x squared plus 3x plus 5 with the corresponding condition negative 3 less than or equal to x less than 2. And the third and last equation is 9x to the third power minus 2 with the corresponding condition x is greater than or equal to 2. So if we were to examine in the first equation, the x values that you can only use is any numbers that's less than negative 3. So negative 4, negative 5, negative 6, and so on. The second equation's x values that you can use is negative 3. And the reason I say negative 3 is because there's less than or equal sign, because that line we have underneath. Negative 2, negative 1, 0, and 1. And I cannot use 2 because x has to be a number for the second equation less than 2. Now for the third equation, if you were to analyze x greater than or equal to 2, so the numbers that you can use is starting with 2 because you have this line right here symbolizing equal to. So you can use 2, 3, 4, 5, 6, and so on for x. So just like before, we're going to start off using the x value that is given in the equation or the question. So it says evaluating using the given function at f negative 3. So our given x value is negative 3. So we're going to test out each corresponding condition, see which one is true, and see which correct equation to use. So let's take a look at the first one. So I'll plug in negative 3 to x, and if you read the statement out loud, negative 3 less than negative 3. Well, that part is not true, and the reason is a negative 3 cannot be less than negative 3. The only condition would be negative 3 equal to negative 3. So for example, if I had 5 less than 5, that wouldn't make sense because we all know that 5 is exactly the same amount as 5. So meaning 5 equals to 5. So reading from that statement and determine that that doesn't make logical sense, so we're going to determine that as not true. So we finished determining that the first equation we will not use, so we're going to move on to the second equation. So we're going to plug in negative 3 into the second corresponding condition of this x right here. So I just plug in negative 3 into the x, and if I read the corresponding condition, so negative 3 less than or equal to negative 3, that is true because even though that it's saying less than, don't forget you have this line right here saying or equal to. So since it has that, then we can say that negative 3 is equal to negative 3. That part is true. Then we have to read the other part of the condition. And you only determine that when you have two inequality signs. So negative 3 less than 2. So we know that a negative is less than a positive number, so that statement is true. So therefore, the whole statement is true. So I'm going to deem this as true. Now I want to double check and see if the last equation, if we had to use that or count that out. So I'm going to plug negative 3 into the last x of the corresponding condition for equation 3. So here it says negative 3 greater than or equal to 2. So it's saying that a negative number is greater than a positive number. So we know that it's not true according to the number line. Negative numbers are less than positive number. So we're going to determine that the last condition is going to be not true. So once we figure out which equation to use based on the corresponding condition that we deemed as true, we're going to be using the second equation. So f of x equals to negative 2x squared plus 3x plus 5. Now we're going to start using the given x value, and we're going to plug it into x of the equation. So when we're looking for f of -3, we're actually solving for -2, or I should say evaluating of -2 times -3 squared plus 3 times -3 plus 5. So you see how all the x's switch out with -3. And again, I'm not messing with f of -3. That's just a notation. We're only evaluating, simplifying the right side of the equal sign. Now, we'll be following PEMDAS. So the one thing we're going to take a look at is each parenthesis. Well, we know that there is a singular number in each parenthesis, a -3 here and a -3 here. So that means that we don't have to worry about parentheses. We can actually move on to the next part, which is exponent. So in this example, we do have an exponent. So here it has -3 squared. So we're going to be focused on that. Now, what I usually tell to my students, even in pre-cal, even in college prep math, is it's always best to expand and then just work from there. The reason I say expand is that you want to make sure you have your number, your correct number, and correct sign. So looking from -3 squared, when I expand, I'm going to have something like this. -3 times -3 inside the parenthesis. So again, the reason I do that is it's helpful for students when they're unfamiliar with integer signs and integer operation. So for example, I have a negative times a negative. So that means that after I multiply, it should come out positive. So let's take a look at this part. -3 times -3, that's going to come out as positive 9, which we have right there. So that's the only part I have to worry about for exponent, because if you look at the rest of the equation, there's no more exponent. So we're finished with the exponent part. So now we're going to move on to the next part, which is multiply or divide from left to right. So I'm going to start on the left side of the equation part. So we have -2 times 9. So we have to worry about that too. And then we also have a 3 times -3. So those are the only two we have to worry about for the multiply or divide. So again, we're going to multiply on the -2 times 9 and the positive 3 times -3. So -2 times 9, that's going to be -18. And then the positive 3 times -3, that's going to be a -9. So when you multiply, you're going to have -18 minus 9, and then don't forget about the plus 5. Make sure you bring that down. So I just finished my multiply divide part. There's no more of those operations. So the next part is add or subtract from left to right. So I'm going to start from the left side. So again, we're multiplying add or subtract. So here we're going to focus on the first two numbers. We're going to do it one step at a time. So I'm going to focus on -18 minus 9. So -18 minus 9, that's going to become a -27. So that's what we have here. And then of course I bring down my plus 5. So after I combine those two numbers, then I'm going to focus on the last two numbers. Again, I'm just doing this one step at a time. So -27 plus 5. -7 plus 5 will come out as -22. So since we got it down to a singular number, I'm finished with the add or subtract part. And basically, there's no more operations that we have to worry about. No more of the PEMDAS rules. So that means that what we have at the end is our final answer. So f of -3 is equal to -22. So again, when you're working with exponent, sometimes it's best to expand, especially if you're working with a third power, to expand out so that way you will get the right number and get the right sign. Like I said before, I suggest this method to my pre-cal students, to my college prep math, even algebra 2, because you don't want to make a simple mistake where you forget the negative sign or you multiply incorrectly. For example, -3 times -3, if we look at this closely, most of the time you should get a positive 9. But some cases where I get -9, and that's an easy mistake because you forget the negative. The other cases where I get 6. So they thought they were adding when they were supposed to be multiplying. So again, it's always best to expand so that you can visually see what you're doing.